Scientific notation. So the book has its way of saying these things. I have my way of saying. A scientific notation, according to the book, is a positive number written in scientific notation if it is written as the product of a number a where 1 is less than or equal to a, which is less than 10, and an integer power r of 10, such that a times 10 to the r. To write a number in scientific notation, first move the decimal point in the original number to the left or right so that the new number has a value between 1 and 10, including 1. Then you count the number of places that you've moved that decimal point. If the original number is 10 or greater, the count is positive. If the original number is less than 1, the count is negative. Multiply the new number in step 1 by 10 raised to an exponent equal to the count found in step 2. So what I say, that was the book. What I say is 1 digit, then the decimal point, then the rest of the number, times 10 raised to some power. And the power is what we're going to have to figure out. So in my example, I have it written the 3.409 times 10 to the 5. Okay, so that 3 point, that's 1 digit, then the decimal point. And the 10 has an exponent on it. No other exponents in there at all. The other one, I have 6.2101 times 10 to the negative 3. So you see the 6 point, 1 digit decimal point. Then the rest of the number, whatever it may happen to be, times 10 raised to a power. The exponent tells you how many places the decimal point should be moved, and it does not tell you how many zeros are in the problem. So here we have a really big number, and I'm sure everybody knows by now that 10 to the 2 is 100, 10 to the 3 is 1,000, and so on. So the positive exponents, we're getting bigger numbers. So I need to figure out what my exponent is going to be on this one. I know that I want to put my decimal point between the 9 and the 3 because I want 1 digit, then my decimal point, then whatever the number may be. So with this, the 3 is followed by a bunch of zeros. I don't need to worry about those zeros. As it's written here, those zeros are just placeholders. So that my decimal point for the original number is at the end of the zeros, but we don't have to write it. So scientific notation, 9.3, 1 digit, decimal point, the rest of the numbers. Don't include the placeholder zeros. Times 10. Now I need to figure out what exponent am I going to put on the 10. So I have to count how many places am I moving this. This is the bump method. 1, 2, 3, 4, 5, 6, 7, 8, 9 places that I moved it. So my exponent is 9. You see that I wrote down the 369? That's a shortcut. You see the commas? That's 3 spaces that you move. So I moved 3 spaces there, 3 spaces there, 3 spaces there. I could have just done 3, 6, 9, and be done with it. So looking at this next one down here. This one, I don't have the commas that I can use. And also because my decimal point is over here, I know that I don't have a big number. So those are, getting to the big numbers. Those were positives, getting bigger. So I'm going to use a negative exponent here. So I need to find where am I going to put my decimal point. One digit, then a decimal point. So this is going to be 1.7. So digit, decimal, the rest of the number as it may be. It ends after the 7. Times 10 raised to a power. So now I need to figure out what is that power. How many places do I move this decimal to get over to here? So I take my decimal, count 1, 2, 3, 4, 5, 6, 7. 7 places. And like I said, this is a really small number. Positive exponents give you bigger numbers. Smaller numbers get a negative exponent. So this is 1.7 times 10 raised to the 7th power, negative 7th power. Third example that I chose, I want one digit, the decimal point, then the rest of the number. So I have one digit, the 1, decimal point, the rest of the number, 94. 1.94 times 10 raised to some power. Is my power going to be positive or is it going to be negative? My decimal point is here, so this is a small number, so I want a negative exponent. How many places am I moving the decimal point? From here, 1, 2, 3. 3 places. So 1.94 times 10 to the negative 3 is my answer. Last problem on this set. 700,000. I don't even want to think about what this number is. That gets up into the national debt type stuff. This one's 700,000. I can think about that. Okay, so one digit, decimal point. The rest of the number. It's all zeros, and all of those zeros are just placeholders so you know where the decimal point would have been. So I don't need any of them. Times 10 raised to a power. Is my exponent going to be positive or negative? The bigger the exponent, the more zeros, the bigger the number. This is a big number. It's going to be positive. How many places? What is my exponent? So I'm going to do that shortcut. There's 3 right there. 4, 5. My exponent is 5. So this is 7 point. You may or may not want to write the point. It's not important because there's nothing after that. So 7 times 10 to the 5th. And we can stop with that. Don't have to go on with that one. Next problem. As of this writing, the world's largest optical telescope is the Gran Telescopio Canaris, located in La Palma, Canary Islands, Spain. The elevation of this telescope is 2,400 meters above sea level. Write 2,400 in scientific notation. So all of that reading just a little bit of work here. Write 2400 in scientific notation. So I want one digit, then a decimal point. So that's 2 point. The rest of the number, 4. These 2 zeros are just placeholders. You don't need to write them. Times 10. Raised to some power. What power? Move it 1, 2, 3 places. Is my exponent supposed to be positive or negative? This is kind of a big number, so my exponent should be positive. Next problem. NASA's exploration rover project landed twin rover Spirit and Opportunity on Mars in 2004 to begin missions planned to last 3 months. Both rovers far exceeded those plans. Spirit worked for 6 years and Opportunity is still active. It is still transmitting signals back to Earth from as far away as 250,000,000 miles. 250 million miles. Write that in scientific notation. That's a pretty big number there. Not one that I'd like to think about, but it's realistic, relatively. So I want one digit, then the decimal point, then the rest of the number. So this is 2.5. Do I need to write any of these zeros? Nope, they're only placeholders. So I stop with the 2.5 and no zeros on the end of that. Times 10, raised to some power. What power? So I have to count how many places am I going to move my decimal point. 3, 6, 7, 8. 8 places. So my exponent is 8. And as I said, that's a pretty big number, so it's a positive exponent. Thousand, million, 250 million, or 2.5 times 10 to the 8. Which one is easier to think about? Now, neither one of these answers is correct. They are missing something. They are missing their units. What were we talking about here? Was this gallons? Was it dollars? We don't know. This was a word problem. Word problems need units most of the time. So now I have to go back to my word problem. The first thing was talking about 2,400 meters. So I need to include M for meters. The second problem was talking about 250 million miles. So I have to write MI for miles. Now my answers are correct. Now I can move on. Now we go the other way, from scientific notation back to standard notation. And we are starting with 9.056 times 10 to the negative 4. And we are being asked to write this in standard notation. So one of the first things that I'm going to notice about this, I have this negative sign here. That is telling me is going to be a small number. Which means that I'm going to be moving my decimal point to the left. So I'm going in that direction. So I'm going to write down my 9056 over to the right a little bit, and I'm going to count out 4 spaces. 1, 2, 3, 4. Now I know where my decimal point is going to be. I need to fill in my placeholder zeros. And if you are going into nursing or engineering, you want to also fill in a 0 in front of the decimal point so that people know that there's that decimal point there. That's just going to be a good habit for you to develop. Put that extra 0 there so that decimal point is more noticeable. Now you don't need to have the bumps there. You can get rid of the bumps. Next problem. 4.8 times 10 to the negative 6. 4.8 times 10 to the negative 6. Again, I'm noticing the negative sign here, which tells me it's going to be a small number. So I'm going to write my 4.8 down over to the right so I have room to make my zeros and fill in over here. I need to move my decimal point 6 places. So I'm starting from here. 1, 2, 3, 4, 5, 6. And there's where my new decimal point is. So I fill in my zeros for my placeholders, and there's my answer. So it's 0.000048. What did I forget about this? It's not a problem if you're not going into nursing or engineering or certain other fields. But if you are, you want to get into the habit of putting that 0 in front of your decimal point. Number 86, 9.07 times 10 to the 10. 9.07 times 10 to the 10. Seeing my exponent here, I notice that it's a positive exponent. That tells me it's going to be a big number. So I'm going to write my 9.07, or just 907, over here. Now I need to fill in my bumps so I know where to put my decimal point, where I should put my zeros for placeholders. So my decimal is starting here. I want to move it 10 places. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Fill in my zeros. Not a very pleasant number. Typically we put commas every 3 places, but you can't put the commas in until you know where the end of the number is. So now I have to count back 3. 1, 2, 3, comma. 1, 2, 3, comma. 1, 2, 3, comma. So my number is 90, comma, 700, comma, 000, comma, 0, 0, 0. Lots of zeros there. Personally, if I were writing this in a business type setting or a science type setting, I would probably prefer the times 10 to the 10 to trying to make sure that I have the right number of zeros there. Next problem. In chemistry, Avogadro's number is the number of atoms in 1 mole of an element. Avogadro's number is 6.022141199 times 10 to the 23rd. Write this number in standard notation. So 6.022. I should have this memorized. One 14199 times 10 to the 23rd. And I want to turn this into standard notation. Right now it's in scientific notation because it has 1 digit, a decimal point, the rest of the number, times 10 raised to some power. Turning this into standard. I want to get rid of my times 10 to a power, which means I have to move my decimal point. Notice here, no negative sign. So therefore, big number so I'm going to be moving my decimal point to the right. So I'm taking that and moving it in that direction. 23 places in that direction. So I start with 1, 2, 3, 4, 5, 6, 7, 8. And then I have to keep going from there. So that was 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. And that is where I stop. I have to fill in all of these zeros. Every last one of them. And then I have to go back and I have to put my commas in. 1, 2, 3, comma. 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 1, 2, 3, end of number. Okay. So my number here, 602, comma, 214, comma, 199, comma, 000, comma, 000, comma, 000, comma, 000, comma, 000. Lots of zeros. What's even better is typically they stop after 2 places here, and they have only 6.02 times 10 to the 23. They ignore all of that. And when you write 6.02 times 10 to the 23, that is a lot easier to write than all of those zeros. So scientific notation is very handy to know. Next word problem. The distance light travels in 1 year is 9.46 times 10 to the 12 kilometers. Write this number in standard notation. Make room here. 9.46 times 10 to the 12. 9. I see no negative sign up here, so I know this is going to be a big number, so I'm starting my number out on the left. I need to move my decimal point 12 places. I moved it 2 there, I need to move it 10 more. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Word problem usually needs units. And the units on this one is kilometers. So I have to put my km for kilometers. Kilometers, kilometers. Okay. My unit for the other one, number of atoms in 1 mole. People don't usually talk about it, but it would be atoms per mole. Didn't put my commas in there. I really should put my commas in there. 3 places, comma. 3 places, comma. 3 places, comma, comma. There. Another thing about these. This 12 here, that told me how many places to move my decimal. It did not tell me how many zeros I have. The number of zeros I have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 zeros. The exponent is 12. I have 10 zeros. That's how it should be. Shortcut to find out how many zeros you have. I have 2 here, so I'm going to take my 12 minus 2, gives me 10. Looking down at this problem, how many zeros do I need? I have, if I can get my marker cap off, 1, 2, 3, 4, 5, 6, 7, 8 numbers there. So I can take my 23 minus 8, and that will tell me how many zeros I need to have. It's a little shortcut if you want to use it. If you don't, you don't. It's up to you.